So we're going to do this, basically this section now, 6.2, is going to be that same stuff, but real life problems now. So those tools we learned, calculator and all that, they're going to see them in real life questions. So probability distributions, real applications of these normal distributions. So here we go. What proportion of men are taller than the 72-inch height requirements for shower heads? I guess there's some kind of height requirement. Suppose maybe some state, I don't know, whatever. The heights of men, let's say, are normally distributed with a mean of 68.6 inches and a standard deviation of 2.8. Find the percentage of men who are taller than a shower head at 72 inches. So here's a real practical question. So if some kind of state is thinking about passing a law that the construction people have to all put the shower heads at 72 inches, so they might want to know, well, what percentage of men are going to have a problem with that? They'll be above the shower head, and I don't know if that's the end of the world, but whatever. So what percentage of men are going to be above that? How can we figure that out? Well, they're telling us that the average man's height, right, the mean, that's the average. So the average man's height is 68.6 inches, and the standard deviation, what does that mean, standard deviation? Yeah, distance from the middle. Good, good. Yeah, glad to see you guys are able to be real with that. Yeah, standard deviation is typical distance from the middle, right? Not every man is exactly 68.6 inches tall. Some are taller, some are shorter, some are a lot taller, some are a little taller, some are a lot shorter, some are a little shorter. There's some deviation from that. How far are they off the middle typically? 2.8 inches. So the typical man is off of the average by 2.8 inches taller than that or 2.8 inches shorter than that. That's the typical distance from the middle. In reality, some are way taller, some are a little taller, some are way shorter, some are a little shorter, but that's the average distance from the middle. So those kind of numbers you can get all the time. Just type into Google, average man's shoe size, and give you the average and standard deviation. So with those facts, we can now easily, and with these things we've been learning, find the percentage of men who are taller than 72 inches. How are we going to do it? I'll draw a picture. You don't have to draw a picture, but maybe that'll help. This is what we're talking about. We're talking about a normal curve. Like that's the spread of all men and their heights. What goes right in the middle?
0.
Well, not for this one anymore. So no longer will we have 0 in the middle. We'll have the mean. Yeah, so we were just practicing all those with 0 in the middle, and the jumps were always 1. That's called the standard normal. 0 in the middle, jumps of 1. But now, the middle is 0. Is 68.6, and the standard jump is 2.8. So that's the middle of the curve. That's the average man. The average man is right here at 68.6 inches tall, and up here are taller men, down here are shorter men, and there's some that are super tall, but there's not many, so that's why the curve goes down. That's the belling of it, right? It goes down, right, really fast. So if you're super tall, there's not many men super tall or super short. So most men are around the middle. Most men are average. So find the percentage of men taller than 72 inches. Now the whole trick is to put the stuff on the curve correctly. And the key is to remember whatever goes up here is percentages. Whatever goes down here is not percentages. So let's take the 72. Where do you think I'm going to put the 72? Does the 72 go up here?
No.
No, because it's not a percentage, huh? It must be a number down here. Because it's not a percentage. You tracking with me? So we're basing, and 72, is that bigger than 68.6 or smaller?
Bigger.
It's bigger. So it's somewhere to the right. I don't know exactly how far to the right, whatever. But that must be 72, and we want percentage of men taller. We want percent taller than 72 inches. So taller. That's like saying bigger, larger. Which way am I going to shade? Right or left?
Right.
Bigger is to the right. Larger, right? Remember last time we did greater and less? Taller means greater. So they want to know what percentage of all men are taller than 72 inches. It's going to be some percentage less than 50%. It's always good to have a rough idea. It's going to be some answer like 30% or 20% or something like that, right? You can tell just looking at the shading. It's less than half, isn't it? Does that make sense? So I want to find now the percentage that's bigger than 72. So, which way am I going to go? Which function am I going to use on the calculator? This whole section is those same two things, normal CDF or inverse norm.
Normal CDF.
Yeah, because I want the stuff up here, I want the normal, huh? If I wanted the bottom numbers, which we will do some of those in a minute, then it would be inverse. Yeah, so I want the normal. So just go to normal CDF. Normal CDF. And what do you put first? Remember how it works? The lower. This is the lower. Oh, wait, no, that's not the lower. I am confused. Yeah, it's the chunk of shading. Yeah. So let me get that straight. So this is the lower. This is the left edge of the shading. And what's the right edge of the shading? 999. That's the upper. Yeah, I was getting off my bearings for a minute there. So it's always the piece of shading that we're talking about for lower and upper. We mean the left and right edges of the chunk of shading. So the normal CDF 72, that's the lower, comma 999, that's the upper. Meaning we want to know what percentage of men are between 72 inches tall and 999 inches tall. How many men do you know that are 999 inches tall? There's no one, right? So that's why that's like infinity, right? That's going to get pretty much all men in there, isn't it? All men taller than 72, I mean, right? Comma. Now, next, we've always been doing 0 and 1, but that's going to change now. No more 0 and 1. What comes next? The mean.
68.6.
Yeah, that's our 68.6. That's the middle now, not 0. And last comes the SD, standard deviation, 2.8. There we go. Put that into your calculator. And I'm getting 0.1123. What? How far do you want me to round here? Anyway, so that is, that's 11.23% of all men. So that means 11% of all men are taller than 72 inches and are going to have a problem with shower head. Okay. See how we figured that out? Questions on doing that? So that's why we practiced that other stuff. So they're just going to go through it. See, they're showing the same thing. They got the same answer we got, 0.1123. And they're just walking through all this stuff. Let's try another one. Designing, and did I go over that too fast? Any other questions on that? Is that good? All is well? All right. Let's do an aircraft problem. When designing equipment, one common criterion is to use a design that accommodates 95% of time. People think about designers, manufacturers do this. When they make, I don't know if you've noticed, they things are getting bigger. Americans are getting bigger over time, right? And when they design, when they design, when they design the equipment, they say let's do a design that accommodates 95% of the population. We have seen that only 46% of women satisfy the height requirement for U.S. Air Force pilots. What would be the maximum acceptable height of a woman if the requirements were changed to allow the shortest 95% of women to be pilots? That is, find the 95th percentile of heights of women. Assume that heights of women are normally distributed with mean 63.7, standard deviation 2.9. In addition to the maximum allowable height, should there also be a minimum required height? Why? So they're getting real on us now. That's a lot of words. Do you like all those words? This is what Brian's always saying to us. At this point forward in stats, it's all words. It's a lot of reading words. And, if you could just figure out what they want you to put in. All right, so a lot of this is reading and rereading and thinking about what they're saying. Let's try to be real with what they say. So before we dive into hitting buttons, let's really, really, really be real. So real, in fact, that I could ask you an interview. Somebody on the street could say, what you're really doing. You can explain in common terms what you're doing. Let's try to get there. So we're designing equipment. We want equipment that accommodates 95% of the population. We have seen that only 46% of women satisfy the height requirement for U.S. Air Force pilots. What would be the maximum acceptable height of a woman if the requirements were changed to allow the shortest 95%? Okay, so let's go on with it. So there's a nice picture of what they're saying. This shading, can you see what they're saying? Represents 95% of women. We want to find what height. There's the average women's height right there. Can you see that? 63.7. So 63.7 right there, the average women's height. And then we want to know how much above that to allow 95% of women to get the shortest 95% of all women. So that's what we're trying to find. Does that make sense? So how do we find that? We're going to go to our calculator now. So that's the first thing they're asking us, is find what height. Notice there's heights on the bottom, percentages up here. It's always percentages in the top of the curve. It's always percentages, right? Up here in the top of the curve. And then down below is something like heights or weights or size of something or other, right? Weights of leaves or whatever. So, am I going to do normal or inverse?
Inverse.
Which one am I trying to find? Am I trying to find numbers up here?
No.
No, they're giving me the number up there. 0.95. I'm trying to find, see that, x equals question mark. I'm trying to find this spot down here.
So you're finding normal.
So I'm finding inverse. Normal's up here, inverse down there. Now, so the normal's up here in the curve, inverse is down here in the bottom. So I'm trying to find this spot right here, the height. If I could maybe lay this out a little bit better. So the middle, the average woman is 63.7 inches tall. I want to know where's the 95% line, meaning what height, put a question mark there, has 95% of women shorter than that. I want to find the 95th percentile for women, is what that means. Are you tracking with me? Yeah. I'm trying to find what height for women. What about if a woman is 6 foot tall? That's pretty tall for a woman. Are 95% of the women shorter than that? I don't know. So that's the kind of thing we're going to find out. Is that making sense what we're trying to find out? We're trying to find out what height for women has 95% of them shorter than that. That's what we're trying to figure out. Right? That's called the 95th percentile. Remember what we talked about percentile a week or two ago? And you guys never forget anything we do in here. Right? Lives on in your mind all weekend long. So 95th percentile means 95% below. Remember we talked about that? So that's why they said it that way too. Anyway, whatever. We're trying to find inverse. Let's go to our calculator, find inverse. We want the number in the bottom, don't we? That's always inverse when you want the number in the bottom. So let's go there. Now, when we go to the inverse, what do we have to have in our hand?
Area.
Area where? Area left. Do we already have area to the left?
Yeah.
Yeah, it's convenient. They gave us that, 0.95. So inverse norm, area left, 0.95. And then mean? 63.7. And standard deviation for women heights? What was it?
2.9.
2.9. Not much different than min. About the same amount of variation. A little bit more, actually. All right, that's it. Hit the buttons.
68.7.
I mean, it's 68 inches, but I'm just saying.
I got 68.47. Is that what y'all got? So 68.47 inches tall. That means right here is 68.47. That means if you're a woman that's 68.47 inches tall, 95% of women are shorter than you. That's the 95% mark for women. I don't know if that's true or not. But I don't know if these are valid numbers, but whatever. That's what this problem is saying. Does that make sense? So, but what is that, 5'8"? All right, we good? The questions on that one? Is that making sense? 68.47. So 68.47, they're using technology like we did. And so they rounded it to, I guess they wanted us to round. So 68.5 inches. Now what was step 4? I forgot. The solution is reasonable because it is greater than the mean. Okay, sure, yeah. A requirement of height less than 68.5 would allow 95% of women to be eligible as U.S. Air Force pilots. What? Wait, I'm confused. A requirement of a height less than that.
So it covers.
A requirement of a height less than that would allow 95% of women to be eligible as U.S. Air Force pilots.
Because it bumped it up to what the minimum height is or whatever, for like 95%.
Was that the maximum height or the minimum height?
The max, sorry.
That's max, huh?
So it bumped it up.
That makes sense. Okay, yeah. So they're saying the maximum height. So they're saying if they made the maximum height for a woman or any person, right? The maximum height for any person. I guess they don't want the people too tall in the planes. Is that what it is? Well, cockpit doesn't have a lot of room, I guess. I'm guessing. So yeah, that's what's confusing me now. I'm getting it's a max. So that's the tallest. So if they made the rule to say you can't be taller than 68.5 inches to be a pilot, if they made that rule, that would allow 95% of all women to be pilots. Does that make sense? That's what they're saying. Should there be a minimum?
Yeah.
I guess so. They could reach the controls. So I guess that's important. Yes. All right. I guess that's a practical question. So are we good there? Does that make sense? All right. To the homework we go. All right. We got 15 minutes. Let's do a couple of these. There's number 1. So so it's just going to be like the last ones. At first, it's going to be totally like the last one. The only difference is they're going to give us a mean that's not 0 and a standard deviation that's not 1. Otherwise, it's the same. So let's do number 1. You'll see what I mean. So on that question, can you see it okay? They're giving me, make it a little bigger here. They're giving me, is that to the left of the, yeah. They're giving me this, they're saying 97. Okay, and the shading. So what do they want from me? Well, obviously they want up here because they're giving me down below. So is that normal or inverse? Normal. Ken, I feel like you're just throwing out either one there. It's got to be one of those two.
I'll hit one. 50-50.
So it's normal above, inverse below. Yeah, it's always normal and inverse. What's a way to remember that? I don't know.
Percentages.
Yeah, percentages above, inverse below. Right. Yeah. So I'm trying to find the percentages. I'm trying to find the normal. Yeah. So I'm trying to find the normal. So it's normal. Or what is it? Norm. Yeah, normal. Normal CDF. Normal CDF. Okay, and what do we do when we do that? We have to have lower than upper. So what's and we mean for the chunk of shading, huh?
Yeah.
For the piece of shading.
The lower would be 97.
Exactly. Yeah, because that's the left edge, and what's the right edge?
Positive 999.
Not positive 999. Because because this is the chunk of shading, huh?
Mean of 100. And then 50.
So lower would be 97, upper would be 999. Yeah, the mean. Oh, you know what? You might want to be a little careful now with that 999 thing because we're doing big numbers now. We're doing like 100 and stuff. So you might want to throw another 9 in there just to be sure. You know?
4 nines.
4 or 5 nines. Be really sure because the numbers are a little bigger now. And then next comes the mean, which is 100, and the standard deviation, which is 15. Right? Didn't make any difference?
No.
You tried them both, huh? You guys are getting quick with those calculators. All right, yeah, I'm getting 0.579. 0.579. 3, I guess we got to round. The 2.5 to 3. Does that look like more than 50% of the area?
Yeah.
Yeah, it's a little more than half, isn't it? Because it starts left of the middle. It's a little more than half. Okay? So these are all the same, the beginning ones. Let's get to the word problems. Let's do a couple word problems and we'll be done.
Quick on number 2, you put 108 as the left, 128 as the
Totally.
right.
Yeah. Lower, upper, 115. Same thing. Yeah, so I think that these ones will be easy. Let's get to the words. That's always what's hard. So number 2 would be the same. Number 3 would be the same. Yeah, let's get to the words. All right, here we go. That's always the trick, is the word problem. So number 4. Assume that adults have IQ scores that are normally distributed with a mean of 100.3 and a standard deviation of 17.9. Find the probability that a randomly selected adult has an IQ greater than 133. Okay, so I'm going to write out the details here. So number 4, oops, I already forgot them. IQ mean 100.3, 17.9. And what was the standard deviation?
17.9.
Thank you. 17.9. Greater than 133. Okay, so there's the question. So IQ, the mean, the average IQ is 100.3, let's say, standard deviation 17.9. That means the average person has an IQ of 100.3, but there's this average variation from the middle. What's the chance you just grab somebody random, they're going to have an IQ greater than 133?
133.
Good, yeah, draw yourself a picture. Yeah, how about I give you a second?
Usually do. I'm watching, like, at the same time I'm doing the homework.
Yeah, yeah. All right, I'm going to draw a curve. You don't have to draw a curve. So, the middle, 100.3. Okay, can everybody hear my voice, please? I don't want to be rude, but people are paying money to hear my voice. Please make sure everybody can hear my voice. All right, so IQ score greater than 133. So the question is, for that 133, is that a percentage? No, so it doesn't go up here. It goes down there, right? Because, I mean, we're going to wrap up with this one, but as we move on to this section next week, going deeper and deeper, they'll play this back and forth game, and the trick will be, because sometimes they'll go, find the top, like 90%. And you'll go, oh, that's a percentage, so that goes up in the curve. You have to keep that straight. That'll be the game we're playing. They'll go back and forth. So right now they're saying, okay, 133, so that's a number on the bottom. Is that to the right of the middle or the left of the middle? Right. Yeah, that's way above average IQ, 133. Now, am I going to shade, you're always shading, huh, somewhere on that curve. Am I going to shade to the right of it or to the left of it?
To the right.
Yeah, because greater. That's why it's really important that you write that word down. It isn't just the 133 that matters, but the greater is a very important word as well. Greater than 133. So I want to shade stuff greater. Okay, so they want me to find what that percentage is. Finding percentages is always the normal CDF. Right, Ken? Percentages are always the normal CDF. All right. So now what do we do from there? We're going to put in lower and upper. And so what is the lower? Lower, upper. What's the lower?
133.
Yeah, it's the lower of the chunk of shading. Exactly. And the upper?
99999.
A whole bunch of nines, as many as you want, as long as it's 4 or more. Yeah. Right? And the mean?
100.3.
And the SD? 17.9. So you all have an answer? What is it? 0339. So that means only 3.39% of the population have an IQ 133 or higher. All right.